All right, hello everybody. My name is Jim Pingle. Welcome to our January 2016 Hangout on creating a DMZ. It's going to be a little bit of a shorter one this month. So if you have any, be thinking of questions, we'll have a little longer period for Q&A at the end. This month we'll be going to talk about some project news as usual. We're going to talk about what a DMZ is. I'll show you a diagram of what one typically looks like. Some things you want to think about when you're designing the DMZ, how you want to protect the servers inside the DMZ, kind of out of the scope for us a little bit here, but it's still things you want to be thinking of. Preparing for the DMZ in terms of getting your network ready and everything else, creating the DMZ interface in pfSense, what kind of services you want to run for the DMZ, make some firewall aliases, make things a little bit easier for managing the rules, things you'll need to think about with NAT, talk about firewall rules for traffic going into and out of the DMZ, then we'll look at firewall rules for your LANs and other local networks, and talk a little bit about isolating your VPNs and things as well. And then, like I said, we'll have some Q&A time at the end. All right, first up, project news. Since we talked last month, our 2.2.6 version is out, which most of you probably already know. So if you're still on an older version of 2.2, go ahead and get up to 2.2.6. Our 2.3 version is now beta. It's coming together really quick, really good. Our release timeline is going to roughly parallel previous D10.3 release, so we're not that much time left before we're going to have it out. So be sure to take a look if you haven't already. You might either run it in a lab, run it a test setup. We have some brave people who are running it in production. All of us are running it in our houses and everything. We're all fine. But it's not something you may want to put in front of a business yet, but to each their own. It's pretty stable. Things have really come together and we're really happy with it. There's only about 50 bugs open to go. It was under that a little bit ago. A lot of those are feedback state too. So the actual number of open ones is quite a bit lower. So in terms of packages, most all the good ones, the popular ones have been converted. I think about the only big ones left are Shirikata and Snort, which we've got people working on. They just haven't got everything pushed out yet. So as usual, keep an eye on the blog and Twitter and whatnot for additional news in between. Okay, first up, we're talking about what is a DMZ. You've probably heard the term 1,000 times, you may not know. It was co-opted from military. Means demilitarized zone, sort of a buffer zone between yourself and your enemy, which in this case your enemy is the internet because, well, it's the internet. It's used to house public services, so you want to keep them away from your sensitive internal systems, but you don't want them just out, out on the internet in general. So you consider it less secure than your LAN, so you don't trust it as much as you trust your hosts on the LAN, but it's more secure than the internet at large. So you trust it more than the internet, but you trust it less than you trust your LAN network. Because because there are public services, they're more prone to be attacked or compromised or whatnot. So the whole philosophy is you want to isolate things. So the DMZ is protected from your LAN, and the LAN is protected from your DMZ. So it's important to have that protection in both directions. And you have to put it on a separate layer too, different switches, different networks entirely. The more separated you have them, the better. What you can't do is just put them on a separate subnet on the same layer too, because there's no security offered there at all. And if something got compromised, they could just pop an IP for your other subnet on there, and then they get access to everything. So that's not good. Don't want to do that. So if you've got proper isolation going, if a server gets compromised in the DMZ, then your LAN's not going to be at a big risk. Your other things in the DMZ are at a higher risk, but we'll talk about that in a bit. So you might see, public servers are what you generally see in there, like the web servers, email servers, might have your PBX, proxies, things like that. Some people also put outbound proxies in the DMZ. Lots of things, basically things that interact with the public tend to go there, especially more so for inbound traffic. So, some people do take it a step further and use separate firewalls for a DMZ. It's more often you'll see it as a separate interface, so that's the kind of the case we're going to cover here. It's just another interface on your existing firewall. But as a lot of people know, Some people don't really realize that the term DMZ has been misused a lot by Soho Gear. What they usually mean by DMZ is they're going to forward all the traffic in from your WAN to a host on your LAN, which is not a DMZ at all. It's actually lowering the security of your LAN without offering any kind of isolation. It's just punching a giant hole in your firewall. So when we talk about a DMZ, we're not talking about like a Linksys or Netgear style DMZ. We're actually, where that's just one-to-one NAT basically. We're talking about a DMZ in the classic networking sense, where it's an isolated network. A little diagram of what a DMZ usually looks like. And then this again could be replicated over, lots more complicated in real life. You got your internet out on the left there, hits the firewall, and then you have your LAN down at the bottom where your clients are. And then you have your DMZ segmented from that, completely isolated on a separate interface. And there could be, dozens, thousands, whatever of servers in there. You could have multiple DMZs, each with their own types of servers and so on. But the gist of it is, your LAN and your DMZ, separate networks for clients and servers. So before you can create your DMZ, you have to design it. There are lots of things you need to consider before you set this up. One of the biggest considerations is whether or not you use public addresses or private IP addresses on your DMZ. Now, your big limiting factor is what you have from your ISP. If your ISP hasn't routed you an extra block of IP addresses, then you can use the public ones there. If you either only have a large WAN subnet, or you could do it with a routed subnet as well. You can have private IP addresses on the inside and then use some form of NAT. Both can be insecure or secure depending on your rules. So, NAT is not going to be considered an extra layer of security, especially when it comes to servers. So, don't let that affect your decision making. If you put public addresses on the inside, you're going to have a lot less overhead, a lot less headaches. Routing is going to be easier. DNS is going to be easier. You don't have to worry about split DNS or NAT reflection, anything like that. You don't have to worry about port forwards, one-to-one NAT, outbound NAT, anything like that. All you have to worry about is firewall rules and making sure your routed subnet comes from your ISP into your WAN. And also there are some services like PBXs especially that do a lot better without NAT involved, where using public IP addresses on there is best. Now, you can't use that public IP address style using IP addresses from your WAN subnet unless you bridge, but that's ugly and we're not going to talk about that. We're going to pretend it doesn't exist. Now, if you choose to use private IP addresses, which is a valid choice, you're still going to need outbound NAT. You will need either port forwards or one-to-one NAT or some other way to get your traffic inside, like HA proxy or squid reverse load balance, the built-in load balancer, whatever. Something is going to have to let that traffic in, translate that traffic from the public addresses on the outside to your private addresses on the inside. And that gets a lot more complicated when you're trying to go between the LAN and the DMZ. You either have to worry about NAT reflection if you have to contact the external addresses, or split DNS, which is a lot cleaner way to pull that off, which I'll demo that toward the end. And there's just a lot more complicated internal concerns you have there. So when you're doing private addresses, one thing you need to worry about too is also you have to pick a new subnet to use for that. It's got to be a private subnet, not overlapping, and ideally one that summarizes with your LAN network. Here on my demo setup for this particular firewall, like my LAN is 10.3.01, my DMZ is 10.3.1.1. They're all under 10.3.0.0/16, or even /22 or 23. Would cover that, a much smaller one. The idea behind that is if you have multiple firewalls and multiple sites, all your networks at a given location can be routed over a VPN a lot easier if they summarize. So, if you do that, if you use IP addresses on your WAN subnet, you will need to use virtual IPs, things like, proxy ARP, IP alias, or CART VIPs, depending on your setup, and just things to keep in mind. There's just a lot more you have to worry about getting just right in that scenario if you don't have the luxury of having a public block to use. Aside from the IP addresses, you have to worry about how you're going to segment these guys. Separate physical switches are the best way to do it. Separate physical networks are the only sure way you're going to isolate things. VLANs are okay for that. They're acceptable in most cases. It's been a decade or so since there's been VLAN hopping bugs and things like that. But in just the right cases, there has been a history of things where you could hop VLANs. It's very, very, very rare, but there is still a concern. So if you're very absolute on your security requirements, insist on separate physical switches. Downside of separate physical switches, it's another single point of failure unless you build up a whole other separate redundant switch fabric, everything like that. It can get kind of, no matter which way you cut it, there are drawbacks. Now, if you're in a virtualized environment, you can just create another vSwitch. That's just fine. How that gets handled down at the lower network level, again, it's up to you and whether they leave separate NICs on the hypervisor or VLANs. That's all separate concern. And you also have to think about how many separate DMZ interfaces you're going to want to make. In this demo, I'm only doing a quick one with just one, but there are some times when you might want a DMZ for your web servers, a separate DMZ for mail, separate one for your VoIP services, separate isolated, more secure one for your databases, things like that. So like I said, when I was starting up, and this is sort of a topic that's a little bit out of scope for pfSense, but it's something that you need to think about. You need to protect the servers from each other as well, because the firewall cannot see the traffic that goes from server to server inside their own subnet. So you need to make sure your servers are protected from the other servers, whether that's a host-based firewall or you have multiple DMZs, in which case the firewall could isolate them. You can limit the exposed number of services that are running on the systems, or you could even consider switch port isolation if the servers don't need to talk to each other. Like say you've got 3 web servers and they will never ever need to talk amongst themselves. You could set up port isolation in your switch such that they can only talk to the firewall and beyond. Then that way they would be segmented at layer 2 by your switches. Downside of that is, of course, they can't talk to each other. So there's some more complexity you introduce there in case you would ever need to introduce some sort of intra-server communication down the road. So all things to keep in mind. That's separate from the firewall, of course, as I mentioned, unless you go the multiple DMZ route. But it's something you need to consider, is that you can't just run these servers naked in your DMZ and expect them to be safe from the other servers. All right, so preparing for the DMZ, so you've decided what you're going to do. You figured out everything you're going to do there for your switches and how you want to design your network, got your addresses all laid out. Then you need to prepare for it. So you need to create your isolated layer 2, whether that means installing your new switches, creating your new VLAN. If you're doing VLANs, you have to make sure that the port that pfSense is plugged into can trunk that VLAN. Or if you need a separate physical NIC, if you don't have a spare port, you might need to, on the firewall, if you don't have a spare port there, you might need to look into adding another NIC, things like that. Or, in pfSense, if you're going to use VLANs on a trunk port, you need to add your VLAN tag. Basically, just getting it ready to be at the point where you're going to assign the interface. When you're hooking all the stuff up, do not try to multi-home servers in the DMZ and a LAN. It's very tempting sometimes, especially with stuff like a file server, where you may want to have a leg in the DMZ and a leg in the LAN, but don't do that, because it weakens your security. Because if that server got compromised, it defeats the whole purpose of having a DMZ. They have, again, full access to both networks. If that server gets compromised. Especially in the cases of things that interact highly with clients, like say it's a Samba server and it's talking to your LAN. There could be a bug in Samba that a compromised client could take advantage of. So it's not something you want to expose. And on top of the security issues, you end up with an asymmetric routing problem. If your client is in your LAN, tries to talk to the DMZ address of the server, that server is going to respond back from its network card in the LAN subnet more often than not, and then pfSense will only see half the traffic and end up dropping it after it doesn't see the reply packets that thinks the connection's dead. So all in all, bad idea. Don't multi-home in DMZ and LAN. All right, so in pfSense, when you're creating this interface, just go up to Interfaces and Assign. You can see here I've already got my DMZ assigned, but if you don't have it assigned yet, it'll show up here in available network ports. You just find it in a list, click plus, and it'll come up as an additional opt port here. Then under your interfaces menu, you go to that opt configuration and check enable. Pop in a description, which I just did DMZ. That could be DMZ_web or mail or web DMZ, whatever you want to call it. You could even just say web servers or servers. Sky's the limit there. I'm only going to cover IPv4 today, but as you can see, I did configure this interface for static IPv4 and IPv6. I give it, the .1 in that subnet /24. That's it. Don't need to worry about blocking private networks or bogons on an internal interface like this. Our rules are going to be handling that. Anything we need to do there. So after you've got your interface set up, save it, apply it, and move on to the next step. Talking a little bit about services you might want to provide. These are all optional. You don't really have to provide anything for the DMZ if you're going to do everything manually or have it contact outside servers, whatever. In my case, I did want to have DHCP on there because it can help you deploy things faster when you don't have to statically program in an IP address as you're configuring the server. If you let it come up, you can find it in the list, manage it over the network if you have to. It's all judgment call there. So I've got DHCP server. I come over to the DMZ tab, enable it, and then just enter a range inside the available range of your subnet. So over here I just did 10 to 50 for a small pool. And more often than not, your servers are going to end up with static addresses. You could assign them static addresses via DHCP if you set up static mappings, which are a good idea. You can set them up that way. You could also set them up as manually static on the servers themselves if you want, or however you want to assign those ranges. That's entirely up to you. You could even leave them dynamic if you have your DNS registration set up and everything to where the clients will register themselves in DNS and it's all internal DNS. You may not have to worry about that. It could all take care of itself in DNS. You won't have to care what their addresses are. But generally speaking, they're going to be static, but DHCP gives you a way to get them online to where you can hit them over the network and configure the rest of the settings without having to do it through a console port. Other local services, just to double check, more often than not, if you left them at the default, they will be able to serve these networks. But things like the DNS resolver here, see, we have a way to selectively assign only certain interfaces for binding if you want. If you left those on the defaults of all, it's going to account for them automatically. However, if some point in the past you went in there and you bound them to only your LAN, for example, if you want to provide DNS service on the firewall for your DMZ, you'll want to say it was on LAN, you'd want to select LAN and DMZ. Same goes for other services like NTP. If you're going to provide NTP service, if it's listening on all interfaces, that's fine. If you had it just on your LAN, you're going to want to extend that to be LAN and DMZ. So just any services that you want to provide to the DMZ on the firewall, you just need to make sure the DMZ is going to be able to query them or hit them if you want. Now, like with NTP and DNS, it's not that important because you could have them hit external servers. You might run your own internal server in the DMZ for DNS. You might have your own NTP server, or you may want to use the Stratum 1 or 2 servers directly. So it's all up to you and what you want to do. But if you do want to do them on the firewall, you just need to make sure that they're capable of answering queries on those interfaces. So the bulk of this is all going to be handled in firewall rules. So we're going to set up some aliases to make things a lot easier for us. First up, make some port aliases here. As you can see, I set up some aliases for like administration of devices. I put up SSH and HTTPS. Mail ports, I've got SMTP, SMTPS, submission, POP3, POP3S, IMAP, IMAP-S, all on there. Monitoring ports, those are like ports for Zabbix, I think, and web ports, just standard 80.443 and 80.80 for an alternate server. So these are just examples. Obviously, you can build off of these or use them directly if you wanted. That's all up to you. I just put those in there to have a good starting point. Over here on the IP tab, I have an RFC 1918 alias that has all the private networks in there that will make it a lot easier to set up block rules to isolate our DMZ. So that's got 192.168.0.0/16, 172.16.0.0/12, and 10.0.0.0/8. For remote administration, that's just something I set up so I can actually still hit the firewall from my test network and lab network. That's just for me. You can set up your own remote admin alias if you want. Because I have to hit this from the WAN for how I manage it in my lab, that's how I did it here. But something like that, you probably would want to use a VPN for. But if you do want to do remote administration, just set that up for whatever static remote networks you've got that you want to track, or you could use a DNS host name, something like that. VPN's preferred, but just as an example, there's an alias for you. And then lastly there, I've got my mail servers and web servers in separate aliases, and they've each got IP addresses that are listed there. Now I'll talk a little bit about how you would want to handle NAT here. If you have private IP addresses on your DMZ, first thing, you need to set up your virtual IPs. Like I've got here, I just had 5 IP addresses for my servers, and I set them up as IP aliases because they're just additional IP addresses in my WAN, and that works just fine. As you can see, I've got 210, 11, 12, 13, 14, all down the line. So if you're using private addresses in your DMZ and you want to use additional IP addresses in your WAN, you're going to need VIPs. So that's just how I set it up here. And in my NAT, you can set up port forwards if you want. If you do port forwards, you're going to automatically get firewall rules that'll pass in the traffic for the port forwards, which is handy. But you'd have to do things a port at a time, which you could use your aliases, like forward in your web ports on this external address into your web servers. But you might want to be careful with trying to do that with aliases in too many places. It can, especially if you try to use it in the destination, you might end up with some unintended results there. One-to-one NAT is how I chose to do this one here. One-to-one NAT does not automatically get firewall rules, so we will have to have our manual firewall rules, which you'll see in a minute. As you can see here, I just did 5 separate one-to-one NAT entries, each for one address. If these happen to align neatly to a subnet boundary, I could have done it with a single one-to-one NAT rule with the right subnet mask, and it could have forwarded in a whole chunk. But just for this example, I chose to do it this way. Now for outbound NAT, what you need to consider here, if you have private addresses on your LAN, automatic outbound NAT may be okay, especially with one-to-one NAT, that'll be all right. Anybody that's not defined in one-to-one NAT is just going to automatically get NAT to go out, and that's pretty safe default. You could set up some manual outbound NAT rules if you want to do things a little bit differently, NAT certain traffic out alternate addresses. Generally speaking, it is good to have, if you have multiple addresses available, it would be ideal to have traffic leave a different address from your DMZ than it would be from your LAN. That way, if a LAN client got compromised, it wouldn't necessarily flag your DMZ address for, say, outbound mail as being, the same. So you may not get tacked onto a spam blacklist for that. However, if you have private or public IP addresses on your DMZ, you need to do one of two things. You can switch to hybrid outbound NAT, save, and then add a rule to not NAT a source of your public network. So that would turn off the NAT for your public network if you want. Or you can switch to manual outbound NAT. When you save, you'll get this big giant list of rules, and then you would find any of the rules that reference your public IP address network and just delete them. Strictly speaking, if you were lucky enough to have enough public addresses to have a public subnet on your LAN and your DMZ, you could disable outbound NAT entirely, but that's a whole different ball of wax we're not going to get into today. Let me just clean these rules up. Set that back to auto because that's the way I'll need it for this. Something I mentioned over here in the slide, but I didn't talk about yet. When you use private addresses on your DMZ, if LAN clients have to contact those servers by name, you might want to set up split DNS. And when you do split DNS, like you can see here in services, DNS resolver is what I had set up on here. I have just a demo web server set up, and I have it set up this way so that clients on the LAN, when they go to resolve this address, they're going to hit the internal IP address. So they're not going to hit the outside and need NAT reflection and come back in. They're going to go directly over to it, because the rules are going to allow that. But somebody on the WAN, if they try to get there, they're going to resolve that to the WAN address, which I'll actually demo that on some clients here in a minute. So something else to do. And if you need NAT reflection, if you can't do split DNS, you just need to go to System Advanced, Firewall NAT, come down here. If you use port forwards, you want to enable this, and preferably use pure NAT mode. Try to avoid NAT and proxy if you can. And one-to-one NAT, or if you have one-to-one NAT, you want to check this box for one-to-one reflection. Either way, if you're doing NAT reflection with one-to-one or port forwards, you might want to check this box down here for the automatic outbound NAT for reflection. Without that, it can get a little messy, and servers may not be able to contact the client addresses back properly. It does mask the source of the traffic this way, so it appears to come from the firewall, which is ideal, especially if you have trouble with it without it. All right, so let's talk about firewall rules for traffic into and out of the DMZ. First, we're going to look at the rules on our WAN. This is traffic for the public coming into the DMZ. As you can see, the top two rules there are handling that. They're passing web traffic into my web servers on web ports, and I've got traffic going into my mail servers on mail ports. So that's all I have here. Obviously, you can expand on that and build it up using whatever servers and ports you want. And if I look here on my DMZ tab, this is traffic, coming from the DMZ host trying to leave. I have allowed it to reach the firewall for DNS and for NTP for time. It can ping the firewall, and it can reach over into the LAN just for the monitoring system, and that's it. No, ideally, you wouldn't have anything at all, but in this case, I just wanted to show you how you could punch one little hole through it. And all of this is above this other rule here, which is going to reject and log any additional traffic that tries to go from the DMZ into any other private network. That could be the LAN, it could be a VPN, it could be a guest network, whatever. If it tries to reach anything that's on a private network, it's going to stop. Now, if you had multiple public addresses, public blocks, you would need more rules for that or another alias to cover your own networks. I use this as a convenience feature, because everything behind this particular demo system is private. And lastly, I have this rule here to just allow anything outbound to, so they can get out to the internet. Servers behind there might need to get out to do OS updates. They might need, if you have an FTP server and active clients, you'll have to allow that traffic back out because they'll need to make outbound connections back to client ports. If you have a PBX, it'll need to get out to your SIP trunks. Mail servers need to get out to their mail. You can be a lot more specific with this. You could, like say, only allow SMTP out from your mail servers. You could, if you know where you're getting your OS updates from, you could limit it to just that. You can be as strict as you want here. In this case, just for the demo, I was being a little bit more relaxed. But if for ideal security, you want to get as tight with that as you possibly can. But again, it's kind of a trade-off, security versus convenience. It's going to obviously take a lot more time to dial those other rules in if you're going to be more secure. I'm not sure. Oh. Somebody looked like they were trying to make a point there. DMZ to not RFC 1918 outbound to non-local networks. I don't like writing rules like that because logically they are confusing for people to see, and they are also a little bit more difficult to express overrides logically. You could certainly combine those both into that one rule, but it may look elegant because it's one rule, but logically it's confusing for people to follow, so I just don't like to do it that way. It's all preference, though. If you want to do it that way, you're certainly welcome to. All right. Talk about rules over here for your LANs, and this would apply to not just your LAN, but also like other local networks that are somewhat trusted. As you can see here, I sort of replicated the rules from the WAN so that they can reach into the DMZ on the right ports. Additionally, they're able to reach into the DMZ on administrative ports, and they are able to ping into the DMZ. Anything else into the DMZ is rejected, and then everything else is allowed outbound. You could obviously adjust these to your liking. Some people take a laissez-faire attitude and they just let everything from the LAN to the DMZ. That's also a bad idea, because if you have a compromised client on your LAN, let's say it's got a virus, or somebody social engineers their way in and plugs into your network, you don't really want to allow unfettered access from your LAN over into your DMZ. A management network is best for the administrative tasks if you can get away with that. Some networks, for one reason or another, policy, rules from on high, whatever, you're not able to set that up. But if you have to, you can allow the admin access, but still you want to be strict with what you allow through there. The general idea is you want to make sure your LAN can't reach anything you don't want them to get to in the DMZ, but yet you still want to let them get out. Now, if this were a guest network of some sort, you might employ the same style of rules I have on the DMZ, where they're not able to reach other private networks at all. Isolating them even further, and then I'll block them from the DMZ, especially if it's public, so on and so forth. If you're running a multi-WAN type scenario where you have, like, these bottom rules might have a gateway set, you want to make sure you do have pass rules to your DMZ for these things without a gateway set. Because if you have a gateway set on things that are going to go to the DMZ, it's going to get shoved out of WAN. It's not going to take the right internal path. So if you go that route, just make sure you're passing things the correct way. And also, for like a guest network, it's really tempting to put a gateway on a rule to shove the traffic out the WAN as sort of a protection measure to make sure they can't reach the DMZ. As long as you have a block rule in place to also block the traffic from going, that's not a horrible idea, but I don't like that idea in general, because there are some scenarios. We have a checkbox that will omit that rule if the gateway goes down, but there are other cases, especially if it's a failover group, where the behavior might change in ways you don't like depending on which gateways are enabled. So as long as you've got block rules in place, it's all right, but don't rely on policy routing alone for isolation. All right. And some VPN concerns. So just like you're isolating your LANs, you need to make sure you isolate your VPNs as well. Like over here, I've got, say, not really a remote access for management type IPsec VPN, but it's sort of set up like the LAN, where they can get to the same ports that are open to the public. They can get to the administration ports because it's it's an authenticated VPN that's a little bit more secure to do it that way. And then they can get to the LAN entirely and ping anywhere. Now on OpenVPN, this particular location has both a remote access OpenVPN and a site-to-site. The remote access, I've just got it open all the way, whereas the site-to-site, they can only get to the LAN. So, just like the DMZ is protected from being able to reach the VPNs, you don't want your remote VPNs to be able to reach your DMZ for the same reasons you don't want them from your LAN. Something over there could be compromised, whatever. Now, you may have to relax that a little bit in some cases, especially when it comes like backups and disaster recovery, replication, whatever. You only allow what those systems need, but still, you might find yourself in a situation where you need to relax those a bit, but try not to relax them more than you have to. All right, so taking this information, you can, that's really the setup for the DMZ. You can take that, you could add additional DMZs as long as you keep the same style of DMZ rules, additional LANs, keeping the same style of LAN rules. Just want to make sure everybody's isolated from everybody else. You could use interface groups if you want. Just be careful of the rule ordering. Interface group rules are processed before the per tab rules. So if you want to pass things into the DMZ that way, for your local interfaces, that's fine. If you have multiple WANs, don't include the WAN in that interface group, because you'll lose your reply to stuff, for letting your multi-WAN work. But if you want to, you can use interface groups or floating rules to make using those rules a little bit easier. You wouldn't have to replicate those rules on so many interfaces. It's not that bad on this little setup because I only had a handful of interfaces, but if you have a lot of interfaces, groups can really help you do that as long as you're careful about the ordering. Just keep in mind that those group rules are going to be processed before your per tab rules. So for passing things, it's okay. For blocking things, it's a little trickier, because you can't make exceptions to the blocks on the group tab or on your per interface tab. It would have to be above any passes would have to be above the blocks, and the only way they could do that is if they're also on the group tab above those. So it gets kind of hairy. So for passing, it's okay, especially for internal interfaces. Just it can get kind of tricky and confusing again. And consider monitoring your DMZ traffic with an IDS like Suricata, Snort. Maybe not even necessarily on the firewall, but you could do like a mirror or span port on a switch that hooked up to a dedicated IDS type system. You'll see that more with like an isolated database DMZ, where if you're in like a PCI or HIPAA compliant type network, they might want to be even more strict with the monitoring and care taken with isolating those database servers that house sensitive information. Well, it's not quite the conclusion because I'm still going to do a little bit of a demo here, but if you have any questions, you can go ahead and start typing them out. What I was going to show you here is how I have this set up for split DNS. As you can see here, the WAN IP address is over here, and my virtual IPs, or actually to show you in the one-to-one NAT, it'd be even easier. This main web server is the only one I actually have up right now, but you see the public address here is 198.51.100.210, and this client over here is actually out. I don't remember if it's on the WAN or on a network behind, some other private network that's not behind this firewall. It's out basically an internet client, when it tries to go there, it gets 198.51.100.210. It gets the public address, and that resolves, from dmzdemo.example.com. When I pull it up in a browser, I get a response from the web server. Now, as I showed you earlier, I'll show it again here under my DNS resolver. I have set up a host override, so dmzdemo.example.com will resolve to the internal address, the 10.3.1.10 address. And this is for clients that are behind this firewall using this firewall for DNS. And so if I come over here to this other client and look, when it resolves dmzdemo.example.com, it comes back to the internal address, 10.3.1.10, and it still gets the same response from the server. Where that's important, again, it's it avoids the NAT reflection kludge if because I really don't like NAT reflection, don't like NAT in general, but NAT reflection especially so. And the split DNS avoids that pitfall entirely. The local clients can talk to it using the local IP. Public clients can talk to the public address, and it's all fine and dandy. Whether or not that works depends on your internal DNS structure and resources you have available, how complicated your things are, and in some cases what the web apps want or whatever server you're trying to reach has got on it. There may be some things that don't play well with NAT. You may have to contact it by the public address, and that gets kind of hairy. If at all possible, if you have to set up something like this, beg your ISP for a routed subnet and use public addresses directly. Get rid of the NAT if you can. But otherwise, that's about it. Let's look back over here at the chat. Let's see. I don't know if anybody has any questions, you go ahead and type them up now. You might type a word or two to let me know to wait for you, and then start typing out the question. I know sometimes it takes a little while to come up there. I don't know, or if there's any other aspect of this particular demo setup you want to look at, we can show that as well. The server behind this is just a dead simple FreeBSD VM with I think it was even just THTTPD running with just a little text file that says ding. See, two-tier web app to MySQL, web and DMZ on MySQL and LAN. I would not put MySQL on your LAN, but it's the same sort of thing. The scenario you're talking there, where if you have your web server on the DMZ and your SQL server on the LAN, it would look similar to the rules you've got here on the DMZ tab. It would look sort of like this exception. It would be above the block here, or the reject, and you would just pass into pass into the specific destination of your SQL server on the SQL port they need. But again, I wouldn't leave your SQL server on your LAN. I would put that in a separate DMZ. I would make, like a DB DMZ, separate from your web, separate from your LAN. Put it over there and allow just the DB ports into that. Sort of the same idea. And you'll see here, something I didn't mention earlier is I used reject on these because they're local, because it gives a quicker response back to your clients. You don't want to use reject on WAN, but on your LAN side, using reject is kinder to the clients. It gives them a quick response saying it can't get there. All right, was that sort of what you had in mind, Sean? Let's see, David said, DMZ with a NAT seems like you just have a second LAN. Can you then have different web filter rules for a second LAN? If you're talking about something like Squid or SquidGuard, that's really up to what you have in Squid and SquidGuard or whatever proxy server you've got. In SquidGuard, you can set up ACLs and do different filtering in there depending on the source, but that's, it's up to SquidGuard. But if you're talking about just plain firewall rules, then yeah, you can have firewall rules that limit whatever you want to do. Sean, oh, you're port limited. You could use VLANs in that case. I mean, like I said, VLANs aren't the ideal top tier security measure, but they are usually good enough. So if you're port limited, hardware limited in some way, as long as your switch supports VLANs, you can set up trunking on your firewall port and tag the other networks coming in and set up VLANs and segment it that way. It's not 100% perfect the way you'd want to go, but it's still better than having your servers in a shared network environment. All right, Arturo, reject versus blocks on rules. I just sort of got there. Reject, when a client tries to send a packet that hits a reject rule, the firewall will send back a negative response, resetting that connection or sending them an ICMP unreachable, depending on what they did. So because that originates a message back from the firewall to the client sees that response and knows that that connection is not going to work, and so it will stop trying. On the opposite thing from that is a block, where if it just gets dropped by the firewall, no response, the client has to wait for a timeout to know that it didn't work. So on internal interfaces like LAN and DMZ, I like to use reject there because it's kinder to them. They know right away it's not going to work. It doesn't just force them to wait on a timeout for something to not work. They'll get an immediate response back. But on the WAN, definitely just want to use block on the WAN because you don't want to be passing out information to the internet at large about open and closed ports if you can help it. All right, anybody else? Check and see. Yep. Trying to think if there's anything else that I might have skimmed over, but it looks like Mark might have some. SquidGuard Hangout. We did a SquidGuard Hangout about a year ago. It's in the archive. You can go back and watch it. Set up SquidGuard, web filtering, all kinds of good stuff. Might do another one sometime after 2.3, but for the time being, the one that we've got up is still reasonably good enough to be still used. So. Traffic shaping, that's something that's on our radar. We definitely want to do a hangout on that, but it's not something we could cram into one hangout. It's going to have to be something we can spread across multiple months, or at least break it down into component topics or something. So it's one that comes up a lot. We want to do it, but we need to find a way to do it that is going to be manageable. What about using pfSense captive portal in the DMZ? That's not generally a good idea because your servers are never going to be able to send out any traffic unless you set up a bypass for their MAC. And if you set up a bypass for their MAC, you may as well not have captive portal. So, I mean, you could do captive portal in there, but unless you're going to log into that server all the time manually, which is kind of a pain, it's not a generally good idea because captive portal, just like it stops your traffic going out, is also going to stop that traffic from coming in. It works both ways. So you really, it kind of defeats the purpose. Michael Kelly, any known issues with traffic shaping in 2.3? I think there might be just one issue in certain cases. PF is misjudging the bandwidth on an interface, and it might cause a queue to not to load properly because it isn't seeing the right bandwidth on the interface. I don't know what the status is on that. I think it's still an issue. But if you use like PryQ, it wouldn't be an issue. If you're using HFSC, it might give you some fits. But I haven't had any problems on my testing on my tests. I'm running it on my edge box with traffic shaping. I've got no problems. But you know, I think there might just be a small handful of people that are hitting it, but we haven't narrowed it down enough to. As far last I heard, we hadn't narrowed it down that much, or enough to know what the problem is. But generally speaking, you'll be fine. And if you get an error, just go back and use PryQ instead of HFSC, and you'll be all right. All right. Anything else? I was thinking there was something else I was going to show you guys on here, but yeah, maybe not. All right. Well, if there aren't any more questions, I'll go ahead and wrap it up. If anybody has any additional ideas for the Hangout, you can post them on the forum, comment on the blog posts, post them on Reddit, get them to us some way, send them into the support address, whichever way you want to handle that. Otherwise, we will see you all next month. Thank you for attending.